Hello, my name is David. I'm going to be presenting our Speckle Hackathon project that's called Speckle Dir Stat, presenting on behalf of the Blue Man Group Understudies. So our project had the concept of this tool that we hacked together was to visualize the density of a model by calculating its byte size and showing in its area and kind of giving you a sense of where in your model there's very heavy geometry and that might be kind of slowing down your model. This is kind of came up from a couple of different case studies that well, not case studies, just moments where we're collaborating with different designers and they might come to us with a huge model like this and they're trying to understand how to optimize it, but you might look at something like this and see that, well, when you calculate it, it's actually only 7 megabytes for this whole entire area, but if you go back to here, you select this area where it's still just the same context, it's actually 23 megabytes. So a lot of designers really don't understand where these heavy moments happen, and it's actually sometimes like hidden in plain sight. So we wanted to kind of create a tool that illustrates that and helps people understand and kind of study and figure out how they can optimize and explore their model. So here, let me just reload this. So in here, a user can go in and load their stream, loads it in like this. And pretty much when the stream loads, all the objects are basically kind of run through and they're categorized and kind of documented to have a couple of key categories. So we kind of keep track of the bytes, the bounds, and we kind of calculate density from how much byte size it takes and how much area it has. So these are kind of the key elements we have here. And then as you kind of are able to go in here and select some of these key pieces, like you can actually go in here on the tree map itself and start to select around and see like where, an element that is colored by the density of its density of itself and kind of scaled by its byte size. You can go in here and actually filter it out and see where something that is, very big is actually not it's taking up a lot of area, but it actually has for its area size, it doesn't have a lot of density. But for something that is really tiny, that they're actually taking up a lot of, it's taking up it has a lot of bytes for a very small amount of area. So the idea with this tool is that users are able to kind of click around and be able to explore this information and kind of filter it and get a better understanding of where they need to optimize to clean things up. So for instance, someone can go like this and be able to click these two pieces here and see that, these are similar areas, but when you actually start to make those curves in a model, it starts to really kind of put a lot of weight onto your geometry. And ideally, a user would be able to kind of separate these pieces out and actually push it into a new commit and send it out and be able to fix it and change it and do whatever and push it back into a new commit from their modeling software. So, and that's also another point of our project here was we built, in order to kind of get this together, we built out a node package for web development that kind of acts similar to the C# API of Speckle, and we've kind of always seen that as something that we've needed in past projects at Sasaki. So this was a good moment for us to kind of tackle that and start to figure out how we build out a little bit more modular component that is flexible and modular. So yeah, so this is pretty much everything, and this is our submission, and yeah, thank you very much.